Okay. Well, our next talk is from our sponsor Airbus. So the presenter is Carlos Gómez Carrasco, whom I know quite well because he did the PhD in our research group, and also is an adjunct lecturer at University Carlos III. In fact, he teaches my course.
Yes.
Okay, so he's going to tell us some things about using C++ in Airbus products. So, go ahead.
Okay, thank you. Thank you, José Daniel, for the introduction. I'm Carlos Gómez. I am part of the architecture team in the Mission System Software Department and Airbus Defence and Space. Okay. First, I would like to thank you the opportunity to be here, and it's a pleasure to represent my team at this event. Okay. First, I will start with the agenda. Okay. Over the next minutes, I hope 20 minutes, no more, I would like to give you a comprehensive overview of the intelligence, surveillance, and recognition system, discussing what they are and their uses in the industry. Okay. I will explain the most significant factors and that impact in the architecture of the system. Of course, hardware and software. We are using C++. After this introduction, we will focus on the communication middleware employed in our solution. We will then discuss the decision made more than 20 years ago to use C++ as the main programming languages in the project, and remarking its strengths and also addressing some of the challenges associated with the use of the C++. Okay. Finally, we will showcase the changes that we have implemented in our software development and lifecycle to become more agile and try to mitigate the issues that we have detected in the use of C++. Okay. Well, first and foremost, the important question now is, what is an ISR mission system? Right? It's important to understand that the definition changes depending on the scope, the company, the objective. It's very changes in the industry. For us, it's a set of elements, of course, hardware and software, both components that work together in a perfectly integrated into a specific platform, and their main purpose is to provide a function, intelligence, surveillance, and recognition, as a part of the tactical network. Don't worry, it's complicated, the definition, but in the next slides, we split the definition in 3 or 4, and it's more clear. We will more clear, okay? First, when we talk about a specific platform, what do you refer? It involves different operational contexts. For example, developing and operating in a UAV, like here, without operator, without dedicated hardware for HMI, is different because we have a more important part in the communication step than in the HMI part. In contrast, we have this classical aircraft. It's the C295 of Airbus, of course. In this kind of aircraft, we have a dedicated crew, a dedicated hardware. We can deploy specific screens, bigger than before, etc. For example, you can see here an example of HMI in this kind of aircraft. Okay? Or, finally, my work and helicopter, in that case a Tiger, that we can have dedicated hardware but only for the back end. To the front end, we need to use the displayed in the cockpit of the pilot. And we don't have an operator. We have a pilot or a gunner that command the system, okay? The type of platform that we can see here, the type of platform also determines the number and kind of sensors. You can see here 1, 2, and you can see here a lot of them. And this also impact in the architectural hardware and software, of course, okay? Next, when we talk about mission, what is a mission here? When the clients define the target and use of the system, of course, he pay, and this mission could be civil or military missions. Civil, we can find search and rescue, support to emergencies, anti-terrorism, and so on. In military, we can have anti-submarine mission, anti-surface, surveillance, etc., etc. Due to the variety of platform, the variety of platform and the wide range of mission that can be undertaken, and also considering that in some cases the clients demand product with multiple roles, not only anti-submarine, can be anti-submarine and anti-surface missions. We need a system that must be modular and flexible to be efficiently adapted. We don't want to redevelop every system in its platform, okay? We need to split our system in a small piece and can reuse all of them. Now, the tactical network. Maybe be familiar with an old proverb that goes, if you want to go fast, go alone. If you want to go far, go together. Okay, tactical network. Historically, this hasn't been the case because its systems worked alone. Okay, the tasks were loaded on the ground. The system carried out its missions, return, and download the data without communication between the ISR and the intelligence and command and control during the mission. With recent technological developments, SATCOM, etc., missions are no longer executed in isolation. Okay, now the information is delivered in near real time and is shared among all the systems in the network. Okay, this means that the information is analyzed in real time and operational orders are issued in the same cycle to all the units in the network. We can readapt the mission in real time. We don't need to wait until come back to the base and start again. Okay. And finally, as a crucial and perhaps the most important part in this context, of course, a mission system is a combination of hardware and software. Of course, okay, sorry. In this image, we can see an example of a configuration of one of the platforms presented before. In that case, a regular aircraft such as C295, okay? We have 4 processors here, 2 CLPs of front-end, with the responsibility of the HMI to the user, 1 TIC, and 1 TMP. TMP is the tactical management processor, which is responsible of aggregating, processing, and shared information. Okay? And TIC is in charge of reading, packaging, and cleaning all the information reading from the sensor. This part is optional. Is optional because if the sensor can share the information via Ethernet, this computer is not necessary. Okay. Also, this computer can be real-time processor. Okay. And the global system is connected with in a LAN with a mission sensor set that we can have the radar, the camera, etc. and with the signals, with the data comes to share with the other parts of the network information, and also with the avionic to give more information from the mission. Okay, and we can observe this creates a distributed system where depending on the platform, the components may be located together, in that case, or not together in a UAV. HMI in ground, backend directly on the aircraft, okay? With this approach, we have this first architecture approach, this first architecture overview, sorry. We have the three kind of processor, TIC, server here is the TMP, and client is the CLP, okay? We have 4 layers: operating system, middleware, infrastructure, and application layer. In the infrastructure layer, we have common libraries such as mathematical library, graphical library, so on, okay? In the application layer, we have a components architecture when each component is dedicated to a specific functionality. Okay? We have one component to translate the information from the radar here, send information to the server of the radar, and server of the radar send information to the HMI dedicated to the radar. Okay. Of course, we have a 3-tier architecture with front-end, presentation tier, logic and data, and acquisition tier. These both can be in the backend and the other in the front-end always, okay? The communication between the parts is clients with server, point to point, client to server in a client server paradigm using RPC. Client to the HMI is in a pub/sub channel, initially Corba, and server with the sensor or driver is point to point, typically using a socket connection, classic socket connection. Okay. Now we detected here some opportunity to improve and to enhance the flexibility across different deployment platforms. Remember, if we can split our problem in more small pieces, we can reuse more efficiently and we can reduce the time to develop new platform. Okay. We decide to go to this approach based on microservices with the main, sorry, need to drink. Each service in our architecture is dedicated to a specific functionality like before. This is not changed. Such a direct communication with a sensor, with the comms of the system, with the avionic, or with any part, with any external part. We can have a server with the functionality of graphical aids, mathematical network, logger, notification, alert, so on. Next, we have a dedicated pub/sub channel. In this approach, we change this Corba to DDS, okay? All the service publish the information in the channel independently who are in the other side, okay? Now, the functionality to display the information has also been restructured into independent services too. These services subscribe to the needed information for us and collect and maybe can talk directly with the server. With RPC, like before. This isn't changed. Okay, we need to operate with the sensor. We need to change functionality, change parameter. The connection must be direct between the HMI to the service. Okay. Seeing this global architecture, we have identified similar behavioral pattern across all the services. Okay. For example, the architecture of the service is the following. We have a dedicated functionality server with the reactor pattern. Remember that we have a lot of asynchronous events in our system. We have 3-layer design. First, controllers, second, business layer or logic, and adapters. The functionality is very simple. Controllers as the entry point of the system. Indeed, in this layer, we have the DDS readers, the RPC server, and an open socket with the sensor, okay? When we receive some requests or some information, we through to the logical layer. The logical layer, we have the core of the system, the core of the functionality, okay? We decide here if we need to request more information, if we need to share the information, or we need to update some database or something like that. When the information goes to the adapter layer, we have the final point of the architecture. We have a very simple flow. In, process, out. Here, in the adapter layer, we have the DDS writer, or the connection with the sensor, okay? Or connected with another services that we need to request more information. We have server RPC here and client RPC here. It's necessary, okay? Well, we have a data publication via pub sub channel, as we said before. All the services are connected to the same channel. Maybe we can split the channel into different partitions depending on the problem, okay? And we have our RPC services for sensor operation, okay? To connect with other services or with the HMI process, okay? Now, let's discuss why we changed Corba for DDS, okay? In our case, FastDDS. FastDDS is a specific implementation of the standard DDS, okay? Yeah, it's a company here in Madrid, okay? In Tres Cantos. What was the nature of ISR operation, real time? Remember that in the definition of the ISR, we said that we need to share the information near to real time. We need a very efficiency communication middleware. We have this with DDS, in our case with FastDDS, okay? Scalability and flexibility. The most important part here is the dynamic discovery protocol. We don't need to present manually client and server. We launch a new consumer, and it's not necessary that the server know it, okay? And another factor is the quality of service. Maybe we need to configure the refresh task of some topic, or maybe we need to prioritize messages one for another, or maybe we need to enforce how data is delivered. Is best effort? No. I need to send the message yes or yes, whatever. And remember, we are EDS, of defense. Security feature is very important for us, okay? This is a military environment. We need to encrypt and access control to the system, to the communication, to the message. And in particular, we select FastDDS because we can run RPC over DDS. Okay, this is very important for us because we can use the dynamic discovery protocol in that case. Okay? We don't need to know where is the server from the client to invoke a process. Okay? In summary, FastDDS offers a robust, secure, and efficient middleware solution that perfectly aligns with the critical and demanding nature of our systems. Okay? And now, the main reason to be here. Okay? Why we selected C++ 20 years ago, more or less. It's not a recent decision. Okay? There are many reasons and threats to using C++. We are in the using C++ Congress, okay? All of us love C++, okay? Of course, but for us, we think that the main reason was, first of all, compatibility with C. Sorry, we have a lot of legacy code, and we need we need to use this code in our system, because redevelop all the system is not an option. Okay. Performance efficiency of a compiled languages. We are close to real time. Related with this, real time capability. Two principal reasons to select C++. Okay, and memory management process. We generate a massive volume of data in a mission. Okay, we have servers, we have sensors that update data every 50 milliseconds. This is very, very massive volume of data. Okay, we need to process it quickly and quickly as possible. Okay, and of course, standard languages. We developed a system 20 years ago with C++ 11, maybe. No, 11, no. No, 11, no. 20 years ago is on C. Sorry. We developed the first version of the product in C++ 11, more or less, okay? And now we are in C++ 23, no? But, of course, we don't need, it's not an option for us, change all the develop, to change or to add a new version or to add a new capability to the system, okay? And object-oriented, we described before a lot of pattern. The main reason to move from C to C++ is object-oriented, and the other reason, okay? And the last one, cross-platform compatibility. We work on Linux, okay? We deploy our system in Linux. But sometimes clients requires the use of third-party software, and this software could be in Windows. And we have two options, principal: virtualization or move my system to Windows. Be able to move my system to Windows is a good point. Okay, we can recompile in Windows. Okay. And every relationship has ups and downs, okay? It's not a perfect world. This is not an issue of the programming language. It's not an issue in C++. It's an issue in the use of C++, okay? No problem. New versions include all the previous version ones. This is a must for us, because we need to use the previous version in my system. But C++ is like an onion. 11, 14, 17, 20, 23, 26, I hope. Please? 29? 29? Yes. 32? Oh, a lot of time. You need to understand the previous version to adapt the system to a new functionality. This is not a problem, but implies a steep learning curve. Okay, it's a problem for us. No, it's a problem for the new team members in the team in the company. Okay, and no garbage collection.
That's the future.
That's the future. I know. I listen to the USA government, but no. The problem here is we have a lot of legacy code. We have a lot of C code. We can have a lot of memory leaks. In the standard of C++, we have smart pointers. Not make new, not make delete. Use a smart pointer. It's possible, unique pointer, and move. It's better for everybody. Okay, but remember, we have a lot of legacy code. The main reason to move to C++ is can reuse C code. It's a problem. Okay. Despite these challenges, C++ remains a robust source for mission system. Anyway, we are still in love with C++, no problem. Okay, we are in the using C++. Okay. Well, to become agile and mitigate potential issues, I mentioned it before, we have made several and significant changes. First, we moved from CMake to Bazel. Bazel is faster than CMake, trust me. It's faster, using caches, it's more reproducible, the compilation process. For us, it's better, okay? Additionally, we upgrade to C++ 17. Yes, we are still on 17. 2 years ago, we was in 14. So it's a very, very important grade, okay? With this standard, we introduced many features to enable our team to write cleaner, safer, and more efficient code, okay? For testing, we use Google Test and Squeeze. Squeeze for high-level test, okay? And Jenkins to improve the continuous implement and continuous delivery process, okay? We can add to Jenkins quality gates and review of coding standard with Selang, okay? Add a quality gate, ensure that every segment is tested and meets our high standard before merging, okay? And coding standard, unify the coding, okay? Unify the code. And this is a must for maintenance and for reducing the learning curve that we mentioned before, okay? And of course, sanitizer, okay? We have a lot of legacy code in C. We need Valgrind or modern sanitizer, okay? Addresses, thread, behavioral, okay? These changes streamline our development process, reduce errors, not all errors, but reduce significantly errors, and guarantee a higher quality final product, aligning with our goal to deliver a robust and reliable software solution, okay? And thank you everybody. First, I will clarify, do you know, the main goal of this task is to show you a use of C++ in a very complex industry like Airbus, okay? Thank you for your attention. Now it's time for questions. Remember, I work in a military environment. Maybe I can answer you or not. Thank you.
You will get your questions.
Okay, no problem. We are here to answer.
Hey, thanks for the talk, first of all. And I would like to ask if in FastDDS or in general in your systems, do you use post-quantum cryptologic algorithms to encrypt information, or you are now trying to migrate to post-quantum or not? Thanks. No,
we recently migrate from Corba to FastDDS, and I think in the next years, we are still on FastDDS. But not quantum computing, okay?
Okay, thanks anyway.
Thank you for the talk. Actually, my question was a bit related to that, was if you had considered other stacks of DDS and why you had chosen Fast over other ones.
We consider other alternatives in DDS, but the main reason for us was FastDDS is here in Tres Cantos. We have a close relationship with the team, and we can run RPC over DDS, and it's faster. Is very close to real time, and for us is this was the choice, but MQTT, RTI is in Airbus. Okay, we use it, but we decide in our case FastDDS.
Thank you.
Thank you for the talk. I have 2 questions for you. The first one is about languages. If you use other languages, as you are working for a military industry, so that means that it's really restrictive in terms of in terms of security and those things. That's the first one. And the second one, why do you tell us that garbage collector is a pain when most of us, we are really proud of it?
Yes. I start with the second question. Okay, garbage collector is not a pain. The pain is the memory leaks. Okay, the memory leaks is a problem. We love to can manage the memory directly. It's faster, it's more efficient. It's a must for us. But if you don't develop carefully, maybe you can have very serious problem. Okay. This is the pain problem. I know this point was be difficult. And the other question is use of other programming languages in the industry. I only I come to Airbus 2 years ago and to the military industry 2 years ago, and I know that we use other programming languages in other application, but not in the final solution. In auxiliary application, we can use Python, for example, or I think so only Python. But I don't know if we use other programming language in the industry.
The question is because I heard from a long time ago that for flight solutions, in the aeronautic industry tend to use Agile.
That
Yes.
was 30 years ago.
See, the first version of the ISR mission system was in ADA, in ADA, sorry. But now we moved from ADA to C++.
Okay, I put myself in the queue. So I'm not going to write a question, but some comments.
Okay.
First, garbage collection. That would be in C++ over my dead body. No way.
I know.
Yeah,
I
you
know,
know,
but
you know.
I need to clarify that for us.
Yeah.
Could be a problem.
And then a couple of
I hate,
suggestions.
for example, I hate Java. Java, we have a garbage collector in Java, and I hate Java.
If you don't have real-time requirements, now a couple of suggestions just to keep in mind. One, let's say, instead, I would suggest that you at least evaluate C++ 20, because if you go to C++ 17, at this point, when you go to C++ 20, you will have to remove a bunch of things. So if you are upgrading versions, once you make the effort, I would suggest make the effort once to 20, because 17 is just a patch on 14, and 20 is a real game changer.
I will give you the phone number of my manager.
Yeah, sure.
You
can call me when you want. Now,
I talk with you every week.
And second observation, you made an observation on object orientation as an advantage of C++. That was when I was learning C++, and I learned C++ in 1989. So I strongly suggest to go through one of the many talks from some parent with the title, "Inheritance is the base class of all evil."
Yes.
First of all, thank you for the talk. I have a question about Linux. Is Linux enough for real time?
Yes.
Or you are
Yes.
you are planning?
We have SUSE real time, for example. I can see. Yes.
Or,
I can say that. Yes. I say it. Okay. Sorry. Sorry.
Yeah. I'm just
it's enough.
question if you are planning to migrate for RT Linux. That is the real time to avoid that the interruptions.
Now we are close to real time, but it's not only real time in our system. Okay.
Okay, thank you.
Wow.
Well, this is really a question to José Daniel, if you allow me.
Yes, of course.
And it is in relationship with the comments you made on garbage collection. I don't have any opinion on garbage collection.
I do.
I do have, but this is not the point. Well, as you know, garbage collection was enabled as an option in the C++ standard and then deprecated. Yeah. As far as I know, nobody implemented it. So maybe you can share some gossip with us as to who pushed for that and why it didn't go anywhere after getting the acceptance, which is not an easy task.
Well, actually, what you said is almost correct. So what was added in C++ 11 was a minimal API on top of which you could eventually build a garbage collector.
Eventually.
In theory, that is.
And eventually.
I said eventually. So nobody implemented. It's unclear that you really can implement a garbage collector on top of that. And that is the reason why I'm not sure at this point is deprecated or removed. Removed. So that.
Garbage collector, well, a runtime, a virtual machine vendor tell us that API is for implementing garbage collector.
I don't want to sound blunt, but one has to wonder why the committee decides to add anything to the standard on the assumption that it might be useful for something and then realizing that it is not.
I might partially answer to that. Well, yesterday I said we make mistakes. The major mistake that we have had in the process was in '98 when we added a keyword export for nothing because nobody was never able to implement. Usually, in most of the cases that there are a proposal, one of the regular questions we make is, has it been implemented? Do we have a reference implementation or at least a prototype implementation? Well, to save my honor and Viles, none of us was there when this was accepted. That was before 11. I mean, but what I mean in a more general way is that the position of the committee of trying to get implementation experience has increased over the past decade compared with what it used to be. It's also true that in the case of garbage collection, this was at some point there were two groups in the committee in favor and against, and having this minimal support sound like a compromise. I don't know if this is enough information.
It is. Thank you very much.
Okay, I feel the need to tell you this because I work for RTI. So we have an experimental API for RPC over DDS.
Oh.
So maybe something you may want to try, although I'm not in sales, so.
I give you mine.
Okay, that's it.
So I'm not going to mention garbage collection again because I think
But I guess that your software is safety critical and must have a somewhat deterministic execution time, right?
No.
Not really?
No,
okay.
Really.
Then my second question doesn't make sense because I was going to ask, like, if you are using dynamic memory, like, allocated at runtime.
Yes.
Okay, then that answers my question.
Not every safety critical software needs to be hard real-time software.
Thank you for your talk. I have a question regarding the architecture.
Yes.
Is there any significant overhead of having multiple microservices running and communicating?
No have a problem of overhead with our architecture. We don't have a significant number of microservices. We have 20, maybe 25 services in the processor. Okay.
Okay. And last question, how do you handle F tiers? At least in space, there's a thing like fault diagnostic and isolation, right? So a critical fault in your system happens, then you have to take action immediately. How do you handle that?
Okay. Depending on the level of certification of your software, you need to manage things immediately, or you can go to a degraded system. For example, we go to a degraded system. It's something wrong. Okay.
This is again related to safety critical systems, but do you use formal methods, mathematical methods that prove that your software is correct and that they are reliable? So in that case, how does that relate to your formal methods? How do they relate to C++?
I don't know. It's not my subject. It's not my team.
Oh,
I don't know.
So it's a different team then.
Yes.
Yeah. Thank you.
Okay, thank you very much.
Thank you. Thank you to everybody, and sorry for the garbage collector.